The last thing we did on Monday, if you remember, was to find the rule from a table. Do you remember doing that?
Yeah.
And I told you that straight lines were always in the form, or could always be written in the form, y equals mx plus b. Do you remember that? Kind of? Yes, you can write that down. I did mention briefly that the letter m and the letter b, they were the two numbers that we had to find from the table. M was how much the y values were going up. Does that sound familiar now? And the b was the number that was underneath the 0 when x is equal to 0. We're going to spend a little bit more time looking at that m. The m represents the slope of a straight line. So that's what we've got right here. The gradient, which is also called the slope, tells us how steep a line is. We are going to be calculating a gradient using this formula. Gradient equals rise over run. Now, instead of writing the whole word gradient, you'll actually start to see that as m equals rise over run. M for gradient. We don't want to write words, we prefer symbols. So m means the gradient, and it is equal to the rise over the run. Now, there is two main types of gradients. Obviously, there's different steepnesses, but they can also be uphill, which means as you're reading the page from left to right, like you're reading a book, you're going uphill for this type, or you're going downhill is the second type. If you are going uphill, that is a positive sloping gradient. If you are going downhill, that is a negatively sloping gradient. And that's what it says here in these next few dot points. If a line slopes uphill from left to right, it's a positive gradient. Downhill from left to right is a negative gradient. There's two more dot points there though, very important ones. If a line is horizontal, okay, like the horizon, flat, then it has 0 gradient. And if we have a vertical line, then that is what we call an undefined gradient. And that sounds pretty complicated. But the reason that is undefined is if you look at our rise over run formula, it means that the run is 0. And you can't divide anything by 0. If you try to do that on your calculator, it will give you a math error. So that's why that's called undefined. So we're going to fill in this table to remind ourselves of these 4 different types of gradients. So it says sketch the following. First of all, a positive gradient is anything that is sloping uphill. Okay, so this is a graphing topic, so rulers are needed. Positive, uphill, like that. Anything going up the hill. If we need a negative gradient, then we are going down the hill. Negative gradient. A 0 gradient is perfectly flat or perfectly horizontal. And an undefined gradient is a vertical line. So those are the 4 main types that you need to look out for. Yes, Joey? As you're, like when you read a book, you read the words on the left and you go to the right, right? Yeah. So as you're on the left-hand side, as you're going this way, it's going up. This one, you're going down as you go across. So you're starting low, going up, that's a positive. This one's starting high and going down, that's negative.
Oh, yeah.
Yeah? All right. Okay. So, has everyone drawn those in?
Yeah.
Good. Example number 1, this is the type of thing you're going to be given. You're going to be given the graph, and most of the time you will have the grid paper behind it, which is super helpful because we are actually going to be counting spaces, rises and runs of triangle. The first thing you have to do is to find 2 nice points on your line that we can use. And when I say nice points, I don't want to pick something like that one. See that red dot that I've drawn? That's actually not a good one. It's good that it goes through the 2, it's on that line, but if I look going this way, I'm like, oh, is that 0.2 or 0.3 or 0.4? Okay, that's not a particularly good point to use. A good point to use is one that goes exactly through the grid, both vertically and horizontally. See how it's going both ways? So your line has to be going through it though. Okay, so that's a pretty good spot to use. This one here, this is another reasonably good spot to use because it is going perfectly through the grid, both vertically and horizontally. And it even goes through my y-axis, an added bonus. Once you have found 2 good spots, and your spots might be different to the person's next to you, you will still get the same answer, assuming that you follow the process, okay? So you don't have to have the same 2 points all the time. There is other ones. I could have chosen this one over here, for example, would have been another good spot. You just need 2 though. What you want to do is you want to start with the highest dot, and you want to go vertically down the grid line and horizontally across to your second dot. And it makes you a little triangle with your line. Now, the triangle is how we work out our rise and our run. So underneath here, I'm going to write my formula down. M for gradient equals rise over run. That's the formula we're going to use over and over and over and over. Rise is, when we rise, we're thinking vertically. How far up are we rising? So you count the spaces. So there is 1, 2 spaces that line, that triangle has risen. So it's a rise of 2. The run is how far horizontally my triangle goes, which is 1 space. So it is 2 over 1. You always have to be on the lookout as to whether it's an uphill positive gradient or a downhill negative gradient. Cash. It is up.
If it's uphill, yeah, it's uphill.
It's uphill. So this is an uphill one, which means my numbers need to stay positive, which they are. So it stays exactly as it is. If it's a downhill one, we're going to put a minus in. These numbers that you find here should never be negative, because when you're finding your rise and your run, you're counting how many spaces they are. You're not necessarily going, oh, that goes through a -1, so I'm going to put that down. You're counting spaces. Does that make sense? Mm-hmm. All right, good. Cash, again.
If it's a negative, would the denominator, is that the top number?
You just put it at the front of the fraction. I'll show you that.
Would it be like higher or lower than the bottom?
It'll depend on the question. We'll have to wait for that, okay? All right, so all I want to do to finish this off, 2 divided by 1 is 2. You're just simplifying the fraction. If you want to, you can do that on your calculator. So that means that my gradient, which is m, is equal to 2. That's it. That's how you find a gradient from a graph. Let's do it again. No. So the first thing we do is we have to find 2 good points on this line now that goes through the grid both vertically and horizontally. So have a little look around. I think this is a good point right there on that 5. And this one here is a good point. So what we do is we draw a line from the higher dot. We go straight down vertically and then horizontally across to the second dot. We're making a right angle triangle. Write the formula down the bottom. M equals rise over run. So remember, we're counting the rise, we're just counting the number of spaces. That rise is 1 space. So it's a rise of 1. Our run, the rise is how many spaces is that little red line I've drawn there? So 1 space.
3.
Our run is 1, 2, 3 spaces. So my denominator is a 3. However, remember the uphill and downhill? This one was uphill. This one is downhill. So this is a negative gradient. So all I have to do at the end is put a minus sign in front of my fraction. So it is minus 1/3. And you always check to see if you can simplify any fractions. Like this one I can simplify, but minus 1/3 will not simplify any more than that. So let's go to our next one. Question 2. Determine the gradient of the line for each of the graphs shown. Find 2 points to use. The -4 goes beautifully through the grid paper. That's a good one. Yes?
Did that last one equal 3, sorry?
No, it was minus 1/3.
Oh.
And you could use this one. That one would work, but sometimes if they go nicely through your axes, they can be really great triangles to make. It goes nicely through that -4, it goes nicely through that -6. That's going to make a really good triangle. So I'm going to use that, even though you could make a smaller one. So from the highest dot, go vertically down and horizontally across, making a right angle triangle. So we need our formula. M equals rise over run. Count the rise. 6. Yeah, you're counting those spaces. It's 6. And the run, 1, 2, 3, 4 spaces. So 4 for the run. Is it uphill or downhill? Downhill. So we're going to put a minus sign in. And that fraction will simplify. Both the top and the bottom can be divided by 2, which means the simplified answer would be -3/2. I would even accept -1.5. It's the same thing. Yes, Xavier.
So could you put the dots anywhere on the line?
As long as they go nicely through the corner of the grid paper. Okay, that's what I was saying in the beginning. We don't want to pick a point like that one there. You can always see it better on yours. It's a bit blurry up here on the screen. Because it's not quite on that line. You'd be guessing whether that's -2.8, or you'd be trying to guess how you want one that goes perfectly through that grid line.
Would you pick a one out like?
But you could have picked. You could, if it goes through the grid, it could, definitely. There's one here, that one there would have been an acceptable one because it goes nicely through. So that would have also worked and you would have got the same answer. Yes, Alex?
Could you turn a fraction into a decimal, or does it have to be a fraction?
It's okay to go to a decimal if it's an exact decimal, like 1.5 would be fine. Don't ever do like a recurring decimal, like don't do something that you have to round. Okay, we prefer fractions for that reason, just so we can always be consistent. Okay, B. Find 2 points that nicely go through the grid line. So the -1 goes nicely right there. And should we do the 2? We'll do that one again. Yep, good suggestion. Yep. So let's go vertically down and horizontally across. Our formula is M equals rise over run. The rise is 1. So it's 1 space. This triangle is 1 space. And the run going horizontally is 2 spaces. Is it positive or negative? Positive, because we're going uphill, so it stays. Does a half simplify?
No.
No. So M equals a half. Final answer. Just more and more of the same. Question 3, let's do it again. Determine the gradient of each line for each of the following graphs. We do have to be a little bit careful here because not all the numbers are shown. You do need to be careful about scale. Sometimes it'll try to be tricky if they go up by 2s, which is going to mess up your counting for your rise and your run. So this first one, where is a nice point that we can use? There's 1 down the bottom, which would be at -5. And
One next to the 2 and 4.
like way up here, I could do that one. Is that what you mean? Yep, cool. There's actually a few of them in between that you could also have used, but the 2 that I've got there will work nicely. So from the top one, straight down vertically, horizontally across, and write your formula down. So Again, checking the scale, even though we've only got -2 and -4, each one of those grid lines does represent 1, doesn't it? Because that would be -1, -2, -3. So counting the rise, 1, 2, 3, 4, 5, 6 spaces. Counting the run, 1, 2, 3. Is it positive or negative? Positive, good, uphill. So 6 divided by 3 is 2. M equals 2. Part B. Can we find 2 nice spots? I think, does it go nicely through that one there?
Sure. Yeah, the 10.
Between the 10 and the 15?
Yeah.
Yep. And right there on that 5. They look like nice ones. So straight down, horizontally across. M equals rise over run. This one's going to be a little bit trickier because of the scale on the axes, both the x and the y axes. So looking at the rise, which is on our y axis here, we're going from 5 to 10, right? So that means that each one space is how big?
5. No.
2 spaces is 5, so one space is 2.5. So it's 2.55, and that would be 7.5. The rise is going to be 7.5. The run. The scale for the run is also, each space is 2.5. So that is going to be just one space, which would be equivalent to 2.5. Is it positive or negative?
Positive.
Positive, good. And 7.5 divided by 2.5 is 3. Yes. You could, for this one it will work, that it was 3 spaces in one space. However, sometimes the x-axis and the y-axis have different scales. So it's better to try and do it that way. Joey?
How do you work out that's 3.5?
Because the 2 spaces was 5, I had to halve that to find out what one space was. So half of 5 is 2.5. From here is 0 to there is 5, right?
Yeah.
So that's gone 2 spaces.
Yeah.
So that means if I only want to know what one space is, I'd halve that 5, so that's 2.5. So each one of these lines means I'm going up by 2.5. So that'd be 2.55, 7.5, 10, 12.5, 15. Yeah? Each one is going up by 2.5. Yeah? Okay. Do we have any more of these? Yes, we do. Good. You've done them. That's great. For anyone who hasn't, let's have a look. I can see a nice spot going through the axes there, and a nice spot going through the axes there. Different sized triangles will give you the same answer, as long as they're going through the grid nicely. So go straight down and horizontally across. I'm going to write my answers on the side this time because there's not really any room below. So gradient equals rise over run. The rise, what's our scale here, Joey? What are these going up by, each one of these spaces? From there to there is 2, but what about just one space? They're going by ones. Yep. So back to ones again. So we can just count 1, 2, 3, 4, 5, 6 spaces. So it will be 6 for the rise, and the run.
3.
Yeah, 3. Positive or negative slope? Positive. 6 divided by 3 is 2. So that's a gradient of 2. You have to write M equals 2. As long as they're ones, it's fine. So I don't have to rewrite it there. I just like to have my whole answer there, but I have written M up here, so it's okay. Part D. Again, we can use the intersection with our axes as nice points. So straight down, horizontally across, and write the formula down. So always check the scale. These are going up, I mean they're only showing every second number, but each grid line is going to be a 1 going this way. And each grid line on the y-axis is also going to be 1s. So let's count for the rise. 1, 2, 3, 4, 5, 6 spaces. For the run, 1, 2, 3, 4, 5, 6 spaces. Positive or negative?
Positive.
Positive, uphill. 6 divided by 6 makes 1. Done. I'll leave it like that for you now, because that's how you can do it. You don't need the M. Or was it Si? Someone asked me about the M.
Thank you.
Yeah. All right, E. Have a go, pick some points. 1 there, 1 there. Straight down, horizontally across. M equals rise over run. So the scale, yes, we're going up by 2, but that's 2 spaces, so that's going up by 1s. So the rise is 3, 1, 2, 3, and my run is 2. Is it positive or negative? Ethan's already ahead of me. Yes, negative, downhill. So put a negative sign in front of it. So you can leave it like that, or you could change that to negative 1.5, but I'll just leave it like that, keep it simple. F. This one does not go nicely through the x-axis, so we might have to go to that point. It does go nicely through the y-axis though, so we can use that one there. So from the top one, straight down, horizontally across. So check the scale. Still all 1s. Every grid line represents 1. So counting the rise, 1, 2, 3, 4 spaces. Rise is 4, run is 1, just 1 space. Positive or negative?
Negative.
Negative, so put that in there. 4 divided by 1 is just 4, so just negative 4 is the best answer. All right, I think you guys should try one without me telling you everything. So how about you try G? I'm not going to do anything for like 30 seconds, and you're going to see if you can get the answers to G, and if you're feeling confident, you can do H as well.
So what's the
Rise over run.
rise is always the one that goes up, right?
Yes, vertical. How are we going? Has everyone finished the first one? G? Okay, so I've just done it and I got M is equal to a half. Did everybody else get that?
Yes.
Yes, excellent. On to H. You already done, Xavier?
Yeah, I don't know how to do next topic.
Ooh. Have we finished H? I got negative 2/3. Negative 2/3? Did anyone make a different triangle to me? Yeah, because I made a fairly small triangle, but you could have come all the way down here and you should still get the same answer, which is perfectly fine. Okay, so you need to do the pages that follow